Okay. So welcome team, session 6 of the Agentic AI training. So this week we will be close to 50% of our training, and we will wrap up with building the um, chatbots. We how to build a chatbot using the RAG architecture this week. And then we'll move into maybe I thought I'll take no code platform tomorrow, but we'll see how it goes, or next week. And from there, we'll move on to the agents. So it'll be interesting sessions. We'll be doing more code. We'll be talking more to the LLM models, interacting with LLM models through APIs and all of that. So as I said, I've few people reached out to me to recap or revise what we did with vector databases and how it is integrated with overall RAG architecture, and to show how we write the data into vector databases. We have also seen retrieval, but both ways. So today is part one of the RAG architecture. So we'll continue, as I said, with RAG with the vector databases. We did FastDB last week. So we'll do ChromaDB and Pinecone today, and we'll go step by step. Again, we'll touch upon chunking strategies, the whole architecture in the RAG, do semantic search basically today. How do you do a semantic search analysis using the vector database? And when we add another layer of LLM model to it, it becomes the whole architecture, RAG architecture for building the chatbots. Okay. Hi, welcome Priya. Welcome everybody. Okay. So let's get started today. Want to go here, we want to go back here. So this is, as I said, I will be doing more of this, right? And we have said in the RAG architecture we use to build a chatbot. So this is the architecture. And then second. So, okay. Okay. So last week we did, if you remember, we did the vector database with FastDB, right? You guys remember?
Yes, sir. We had a Python notebook where we had few.
So anybody have downloaded and also shared the document to create OpenAI API keys and the Google Colab. So anybody have executed that used the API key? I know Bala, you have tried to created the API key and you created the notebook, right?
Yes, yeah.
Yeah.
I was able to the Python notebook. I was able to change some sentences to see what was the upon changing what was the scores and things like that, just to play around.
So as we talked about last week in the vector databases, I will go back here, right? And then let's see. So we learned about how we can generate embeddings and how they are grouped or spaced in the vector database based on the embedding, which is again based on the features of what we are trying to put the data. It might be text, sentence, word, paragraph meaning whatever, right? So this is the entire architecture we talked about. The internal documents, whatever the organization has, whether it is CSV files, PDF files, or a relational database or text documents, whatever, we said we'll process all of that, break it down into smaller chunks, pass it to an embedding model, and then that embedding model will generate embeddings. And these embeddings we store in the vector database. Can you hear me? Yes, Lakshman? So this is and when the user asks a question, we convert the question also into the embedding, because in a vector database, it enables you to search based on embeddings. And when we said there are two limitations, or hard and fast rules, if you say that you should, whatever model you are using here to generate the embeddings for all of this source data, your library, this knowledge base, you should use the same model also to convert the user question into the embeddings. Only then you'll be doing a apple to apple comparison. Your search results will be accurate. So this part up to here, you get relevant results is all about the search criteria. This is about the semantic search, applications. So this part is good enough if you do like, recommendations based on past history and, such kind of up some of the applications that you can use. But then if you want to give a proper answer, it's not very, it's very crude and raw information, because you're just trying to pull some text from any of these and then throwing it, and to the user, saying that your information again lies in some of these chunks, some of this data, right? It's a raw data. If you need somebody to process that and give you a properly documented, user formatted, user readable answer, then you add a model to it, and then that's the entire RAG architecture. That's your chatbot, right? So this is what we talked about. You have a content, you have embedding model, the application that sends the data. You break it down into vector embeddings, put it in a database, and the application, you do a search and then send it to application. So this is the first part, content that goes through. This is the second part, application or the user question that goes through and get the results back to application. So now, as we said, we talked about the FIAS-DB. So today we'll talk about the ChromaDB. Again, as I said, in the ChromaDB, it has three modes, right? One is the ephemeral client, which is the memory, in memory. The second is persistent, where you can store it on the onto the system, onto the machine, and then reload it when you get back. Okay, you can reload it when you want to continue from there, from the wherever you have saved last date. Client server mode, again, it's on cloud, where you can talk directly to the cloud, create a database there, and it is also persistent. So you can read and write information there, and it stays just like your regular databases. So these are the three modes for ChromaDB, and Pinecone is anyways the client server mode that we have. Okay, so what we'll do, let's go to ChromaDB. I'm using ephemeral client. Okay, so just the client here. All you have to do in memory, install ChromaDB, pip install ChromaDB into this. Okay, and you import the library ChromaDB. So your entire Chroma database is installed in memory here. Okay, and using that, you can create collections. Now, how do you create collections and all? We'll go there in a bit, where we'll do with Pinecone. Okay, now as I said, every platform, they have something called a, they have something called the a model, right? So you're generating the embeddings, right? So you have uh, every vector database is tied. You can create collections with some vector databases, and then that collection is what stores the data. So when you create a collection, you have to mention what is the dimension and all of that that you do for that. But as I said, some of the databases by default have their own models that they can use when you create the collections, even if you don't pass the embeddings. So in that case, what happens? They can automatically use whatever is default model they have, and you don't need to specify a model. So both your library and your application. So if you go back here and look at this, right? So here, this embedding model, this you can most of the times you will give explicitly, but sometimes the database itself hosts some of these models on their own platform. So you can choose one of those default ones. Then you don't need to provide your model. It will, whatever content you pass to database, it will automatically embed and store. And question also you pass to database, it will automatically embed as a pre-step before doing the search. Okay, so let me try this. I'm not sure the digital pen has some issues. If we go, yeah. Right, that's fine. That's not working. So there are two options. One, you can give your model, or you can use default where the vector database is already having it, right? So let's see what it does. Now I have this. I'm creating a ChromaDB client to talk to the ChromaDB, and then creating a collection, cohort 8 collection. So this is uh, the boilerplate code, you can say, simply downloading this ChromaDB library and installing. So again, I said this ChromaDB is very, very useful in doing your POCs. Okay, it's quick, fast, in memory. You don't need to build or bring up your VMs or machines or cloud or whatever. You can just build, or you can create a ChromaDB FMA, the persistent client in a VM machine, in your virtual machine or whatever. So it's quick. You can create the ChromaDB and connect to it. So I have already created. Now I have collection called cohort 8 collection. So what I'm going to do now, I'm creating all of these documents or sentences. You can say I'm using it as documents. So each sentence is a document, you can say. These are similar kind of sentences: cold and windy, hot and dry. It's about the weather, both in Hawaii and normal, right? And I'm giving ID to each of these. So I'll go ahead and just add all of these documents to the collection. So what are we missing here? What step are we missing here? We created a vector database, and then we are adding the documents. So what step are we missing here?
Chunking.
Chunking and
Embeddings.
embeddings, right? So we are missing the chunking and embeddings. We are not doing that here. Okay. We are just taking the documents and adding it to the collection. Now, what happens when you don't do any of that is, so if you see here, there is Chroma, Onyx models, all mini LM L6 V2. So this is the default model that the Chroma DB is using to do the embedding. As I said, it will automatically do the embedding and store file. We'll see explicitly how we can use the model. Again, last week we have used our model, embedding model. So this time, it is how the Chroma will automatically use the default model it has to embed these sentences. Now that the collection has these sentences and we have added it, now let's go and see the results. So I'm just creating a function where I want to query this vector database for any of my questions. Okay, so I can do any question and then I want to get the similar results, similarity search. So here, number of results, I want 2 results. Okay, now I'm just writing this print statements. So let's run this. Collection.query, tell me about Hawaii. This is my question, my user question to semantic search. Now, what it has returned, if you see, I asked for two results. One is it returned 2, ID 5, ID 3. What is ID 5, ID 3? So these are the ones. 1, 2, 3. The weather is nice in Hawaii. ID 5 is it's a beautiful day in Hawaii. Okay. So I just asked about, the question was, tell me about Hawaii. Okay. Using the embeddings, using the semantic meaning, it found out these are the 2 sentences that are closer to what we are talking about. Okay. So we got these 2 results. Now, if you look at the distances, it's 59 and 69%. Now, if we keep this results, increase this results to 3, so I will get a third result now. And then it says summers are hot and dry. Okay. But the distance is too high, 1.44. So it's farther away, much farther than these 2. Okay. Now, if you give 4, you will get another result, which is again more irrelevant. See, 1.6 is the distance. Remember we talked about the more farther they are, they're less relevant to our search. But since we asked to give as many results, it will keep getting more and more, distant neighbors pull in based on your request. Now, we said, okay, we asked Hawaii. It found some Hawaii in there, and then it gave the results, right? That's all good. But how do we make sure, how do we check that it understands the meaning of the question that we are asking? That's one thing that we'll do. The next thing, again, as we said, we have not used embedding model here. We are also not using any embedding model here because it's a Chroma will embed this for you because it has already the default model. So that is what we used. And then we are adding directly just asking the question, and we are leaving Chroma to use its inbuilt or on hosted model, which is this one, to embed and do the search for us. Now, how do we get the meaning? So I want to ask a question, right? Generally, like ChatGPT, what do you ask? You don't give the exact same word. You just say, hey, when does it looks like, it's freezing? When does it look like freezing? I asked the question. Now, looking at the source, what do you think it should pick up the answer? I'm asking a question. When does it look like it's freezing? So when is it freezing? Based on, it cannot give its own answer here. There is no LLM model. We are only talking about the vector database. And it's just like a database. It will search the database and get the results from whatever it's there. So this is the information we have in the vector database right now. These are all the documents. These are all the information. So when I ask the question, when does it look like freezing? What results do you get? So I'm asking how many results? Top 3. So which three do you think should be returned or relevant to that question? When do you think it is freezing?
1, 6, and 7.
Sorry, Bala.
Last two lines and the first one. 6, 7,
It is a very harsh
and
winter.
1.
Okay.
Yeah.
Temperature is very low. Okay.
And the first one.
Cold and windy. Okay. So how did you know that? You know all of these three?
I mean, that is like, for us, we can understand. Yeah, I want to understand.
Yeah. So understand how? Tell me. Logic.
The temperature. It's all related with temperature.
Yeah, temperature.
Low
Right?
temperature.
Yeah.
Low
It's all
temperature.
related to temperature. It says you think that if it is cold and windy, it can be freezing. When the temperature is very low, it goes very low, it can be freezing. And if it is a very harsh winter, generally freezing. So models also look at, when embedding models, right? So they have seen data relevant to harsh winters and all of these. The term freezing comes very often referenced in this context. So that is understanding the context and understanding the meaning. Because in our question, there is no word in common, not like we said here Hawaii, and then you can look for Hawaii directly, right? So there is some Hawaii connection here. So you can, okay, what's big thing? You looked for Hawaii, there is Hawaii, and then it picked wherever there is Hawaii, it gave the relevant results. But here, we don't have any common word or sentence or meaning, say substring to search for exactly, right? None of these sentences have anything called freezing or anything like looks like or anything, those common words, except for say it does. Then even those, I don't think only it is there. That's it. In 4 or 5 sentences, nothing else. So that's, it does not have any meaning. It means does not have a meaning. So it's not really relevant. Okay. Now let's run this and validate what Bala has said. Awesome. See here, the results. The temperature is very low. It's cold and windy. It's a very harsh winter. So these are the neighbors or the closest sentences that appear in the vector database stored, which are close to this sentence. Okay, it's like, based on the embeddings test generated, this is the sentence. Distance 1.1, 1.2, 1.29. So these are the closest ones. Though the distance is far, but still those are the closest ones we have. Now, if I say 4, you would get another result, which is obviously farther. It keeps go farther away, right? To add. So this has nothing to do with our freezing. It talks about summers, right? But then there is no other information that we have that talks about freezing here. So that's why it has come to this. Summers are hot and dry. Okay, so this is how you get do the semantic search. How vector databases are useful, embeddings are useful to do the semantic search, to understand the meaning and search and get the relevant results, the nearest neighbors, right? That's how it does. Now, let's say we add some more diverse document sentences here. Now we are adding like artificial intelligence is rapidly transforming industries. Amazon rainforest is incredible biodiversity. Van Gogh Starry Night. So look here, we have diverse topics. One is last thing here we talked about all weather conditions and all of this. Here also we talked about one similar topics, right? All of this, but here we are trying to add some diverse topics. One is about artificial intelligence. One is about rainforest. One is about art. One is about games. One is again quantum computing. Again, coral reefs, marine ecosystems, Renaissance art, football, soccer, blockchains, Mount Everest. So we have diverse topics here. And then we are adding all of these documents to our collection. So you add collection.add. These are the new documents, and I gave some IDs to store. So when I add this, now our library have all the collection. So let's say I'm asking different questions now. The question I'm talking about is, tell me about advanced computers and quantum technology. So if I ask this question, so what do I get answers? It gives me about quantum computing. I know you have quantum here, something related to it. So you got quantum computing. Then you got artificial intelligence. Then you got blockchains. So these are the tech-related topics that we have. And as you see, because quantum is mentioned here, quantum computing is mentioned here, this is the closest, 0.73. That's the distance. Though these are also tech, but these are a little bit farther away in the space, right? So if you see here, so if we talk, if I say, where is this? Yeah, something like this, right? Now, so we're talking about the AI. So if we understand if this is the same vector database, right? Now, if I'm adding something about quantum, artificial intelligence, or any tech, where do you think those dots or those embeddings live in this space? Take any of these examples. Does it fit into Berlin, Denver, Tokyo, Apple, Goa, Orange, Parrot, Sparrow, Pigeon? Anywhere? So let's say I want to put the quantum tech sentence into this. So where does it go and sit? In a assume two-dimensional space here, or three-dimensional. Does it go into any of these circles?
No.
No.
No, right? So let's say assume imaginary, it creates another circle here and then say these are tech or AI related, right? Now, all our sentences about artificial intelligence here, quantum technology here, and something else will be here. Now, if I ask a question, so what is my question? If I ask a question, where is this? Stock. Sorry. Okay. So tell me about advanced computers and quantum technology. Okay. So if I ask that question, and we say it goes here, right? Now the question, when it is converted to embeddings, it will fall somewhere here, right? And we know the nearest neighbors are these three within this. So it does not go to Parrot, Sparrow, or Denver, or whatever. These are the closest ones. Now, same thing, if you're talking about Amazon rainforest or coral reefs or something like that, so there will be another circle, or so don't again get into the circles, okay? It doesn't create any circles just for representation. Maybe I'll just remove this. So let's say Amazon rainforest, we are talking about, that sentence comes here. Now we are talking about coral reefs, so that sentence might come here. Okay, we are talking about the mountains, that sentence might come here. Okay, so when you ask any question about natural landscapes or in general about the preservation or climate or anything about mountains, coral reefs, or any of rivers, forests, anything. So that question will come and sit somewhere here, maybe, right? So what are the nearest neighbors? When you ask for top three, obviously it's going to find this closest one, and this closest one. So it'll pick these. Now, if you ask, give me 50 results, okay, I have this top three. So where do I get my fourth one? So it goes there and sees, okay, this is my next closest one. So obviously you'll get into the unrelated information, which is in tech. So it gets, okay, these three again, and I need more. So then it goes and gets your parrot, pigeon, sparrow. Then it goes and gets apple, guava, orange. So you understand? Basically, your question based on the embeddings, it falls in the space somewhere here, and these are your nearest neighbors. So how many results you want to get gives you, based on the distance it calculates and how you can get those results as a semantic search and based on the meaning. Okay? You guys got this? Any questions?
Yeah.
It's better. It helps you understand.
Yeah.
Okay.
So is that also called hallucination? Is that something we can interpret that as hallucination, where it's not really
No. Wait, so we are not into hallucinations yet. Hallucination comes when we are using the vector database. Sorry, when you're using the large language model. Here it is only semantic search. Here it is only, we are talking about embedding models. So there's not hallucinations. It's not generating any answer for you. It is only searching and returning only whatever is there. Here there is, if you look at the results, nothing is being generated yet. It only gives you the existing lines or existing sentences, existing paragraphs, which is there in the vector database based on the search criteria. It's just like SQL, select star from this database where, the text is like apple, like percent Goa, percent orange, something like that. So when you write a SQL, it will either give you a result from database or it will not give you a result, but it does not create a new sentence for you, right? So we are there, we are not there yet. So we are simply just now trying to do a semantic search, filter the results from the whole library that we have built, knowledge base we have built from our internal documentation. Take, for example, the your customer support or troubleshooting guide. Okay, let's say you have a chat bot. Customers, you have given it. You want to reduce the burden on your agents for customer support, tech support. So first thing, you will give the chat bot to the users. Make it try. They say they can do it themselves. Do it yourself. Solve using the agent. So the user types a question and you have to suggest an answer. How do you suggest an answer? I have my troubleshooting guide where I put my FAQs or like top 500 issues that I think might be, say my washing machine is making, throwing this error code. It's not starting. So in my troubleshooting guide, somewhere I have put error because I know, right? So I'm the washing machine. If I get this error message will come. So this you have to do reset or run a self wash cycle something or clean something in the lint or something and then restart. So I put there in the troubleshooting guide. Apart from that lint, there are so many other questions also, tickets also related to that. Not the same error message, but something related to that. So when the user asks the question, right? The user asks the question. The user asks the question here, okay, about the washing machine, and then you have all your customer support tickets. It can be earlier tickets that were worked on the similar kind of error message and what fixed it, or your troubleshooting guide questions, 1, 2, 3, 4 error messages that you have, and customer is referring to something called lint problem, and lint is mentioned in 2 and 5. So when the customer asks this question, the machine says there's too much lint, it will go and search for that, and it finds these two as relevant. And this will return these two as, okay, try this kind of. So that is how we are doing. It's not trying to answer anything from the internet, or it's not trying to answer from the model. It is strictly trying to get from your corpus, from your library,
Right.
based on
Okay, a
this.
couple of questions, Harun.
Yeah.
So is there a way where we can say, in your previous example, like when you asked for three, it gave the right three, but the fourth one was not really the right answer, but it still gave because we asked for one, right? So is there a way when we're developing an application, we can say, give wherever the score is less than 0.75 or zero point 0.9? If you go
That's a
back to
good
your
question.
example.
That's a good question. So there are two things that you should do when you are creating your application. First thing is, based on your embedding model, based on your vector database, based on the algorithms that you are using, like, we talked about cosine search, we talked about dot matrix, right? There are 4 different algorithms to search. Based on what you are using, you will see what kind of results. Like you said, you are only seeing top 2 as top 3 as my relevant ones, fourth one is not relevant. Then you looked at the scores. Now, this is kind of your configuration, training kind of your application. So now you see anything that is less than, so I should get only 3 results. You can, first thing, you can go back and say, I want only top 3 results. Okay. That's one thing that you can set and say, only give me top 3 results. Right. Second thing, so here you can say how many results you want. Second, once you get these results, it will also give you the distance. So you can filter these results based on the, as you said, the configuration. Okay, give me only less than, take only less than 1.5 or 1.6, whatever is the distance based on your knowledge. Third, you can pass these results to a model and then ask it to re-rank and select the top 3. So that is also called re-ranking. That also you can do. So there are several ways of limiting your results before you send it to your model, large language model, to generate an answer. Okay. So yes, so these different things you can implement, but you cannot directly ask it, how much work, give me only relevant results. It does not know, because there is no knowledge built in. There's only meaning, search index. You're only doing a semantic search based on embeddings. So once you get the results, it's up to you to define these parameters. How many results should I get? How do I do the re-ranking? How many I should consider as valid? Right? These are based on your results, your pre-training, before you build the application.
Got it. Thanks. So one question on the Python notebook here. So this is an ephemeral, right? So when we created this ChromaDB, it is for the context of this session only. Is that right? Is that how it is?
Yes. Next time if you go,
Um,
so if I just, let me see, if I go here, I will just say restart session. Yes. Now, if I just go and run this, no, collection is not there. Okay. So basically the variables collections itself is not there, and the database is also not there, basically, once
got
you
it.
come out of it. Okay. So yes, you have to do the semantic. So this is, even others, yeah, if you run it, the data is not there. Okay. So even if you have the collection from there, it's a new instance that will be created when you run it again. This one.
Got it. And is there a limit for the session, or is it Like normally, if you go to
This is all about the
ChatGPT,
cloud. Yeah, it stays as long as you're working with it. And if it is idle for some time, it goes away.
okay,
And then you can run parallelly 3 or 4 sessions. So it's up. So once you keep working with this, it will stay.
thank you.
No. Okay. Okay. All right. So that is about how we work with the Chroma DB. Any further questions? Now we'll get into the Pinecone to do the same search results. So for the Pinecone, we talked about vector database. So I'll go here. Any questions?
Arun, I have a question.
Yeah.
The distance that it is calculating, how it is calculating exactly? So you gave the collection
Mhm.
and it gives the number, right? It is based on what?
It is based on the algorithm, the vector
The code that
databases.
you executed, right? So
Yes.
how that it is calculating the distance?
How? Sorry?
The distance, the numbers which are coming
Yeah.
from that distance, is that based on algorithm or based on
Yeah, based on
semantics?
one of these algorithms, cosine similarity, dot product, or Manhattan, or Euclidean. So one of these it uses. So let's see which algorithm ChromaDB uses for calculating distances. This is your first question between 2 points, right? So it says approximate nearest neighbors HNSW, then squared L2 Euclidean. This is the default distance metric. So these are the ones that it uses to store the indexes. Basically, it's two ways. So first thing is you have to understand these are two different components of the vector database. First, it has to store all of these dots in the spaces, right? How does it store in the spaces is based on your, where is this? Let me put this on one slide.
In this case, you have given on the left side.
Yeah, so this one.
animals or-
So where does it store? How does it store in the database is based on the these algorithms, approximate indexing. How does it index the points, embeddings in the database, approximate nearest neighbors and hierarchical HNSW to index the embeddings efficiently. This is about the storage space. Okay, where it stores, how it stores, kind of a thing. Now, after it stores, how does it calculate distances between these 2 points? So that is the squared L2 Euclidean distance. This is the default distance metric. Okay. Now there is a formula. This is also relates to cosine similarity. 2 star 1 minus cosine similarity. So this metric gives angle between vectors. So it uses this. Okay. Now, if you want to go again, dig deeper into statistics and math behind this, how is Euclidean distance? What is Euclidean distance? How is it calculated? You can also go in there. Okay. So let's see. We go here and then ask what is the math behind. Let's say I'll ask Euclidean distance. Vector. So it gives you, hey, for two vectors A and B with n dimensions, this is the mathematical formula. It is used to calculate the distance in a multidimensional. Now we know we are seeing this here. This is 2 dimensions only. But we talked about, right? Model can have 1,000, 1,500, 5,000 different n dimensional space. It's not a 2-dimensional space to calculate. Two-dimensionals, we know square root of x2 minus x1 whole square plus y2 minus y1 whole square. We know the math formula to calculate distance between 2 points on a x and y coordinates, right? So that it becomes math and stats. Same thing, sigma I equal to 1 to n dimensions. So for each dimension, you have to calculate those distance. A minus b whole square. So these are the points. A and b are the vectors. So something like that mathematical formula. You can also you go subtraction, difference between coordinates of each corresponding. So x2 minus x1, x2 minus x2, y2 minus y2, something like that. And square those differences, sum them, and then take a square root. So doing all of this, you get number. That is the number. It gives you 1.2, 1.4 or whatever. Okay. So then if you want to see cosine similarity, how does cosine similarity works? Right. So hear me? I think there is a internet glitch. Hello?
Yeah, we can. Yeah, we can.
Okay. So
Yeah.
did you lose me in between?
No, no.
So this is this, if you want to find how the, based on Pythagorean theorem, how the Euclidean distance is calculated, this is the formula. If you want to see cosine similarity, how does cosine similarity work? This is the formula for two vectors, A and B. This is the mathematical formula it uses to calculate the distances. One, the vector point is in the exact same direction, zero angle. Vectors are perpendicular, vectors in opposite direction. So if the distance is actually written as 1 minus, this means a distance of 0 is a perfect match and 2 is totally opposite. So you have to also see when it is returning the distance, is it directly returning it or inverse, like basically trying to do the opposite thing and giving it back. Normally, if it's straight result gives you the result, the more the distance, they are less similar. But if you do 1 minus, then it becomes the opposite. Okay. So this is the math involved. You can explore for each of these, but basically these are the 4 different types of, as we talked about, algorithms that any of these model uses. Now we said Chroma uses Euclidean and cosine similarity. That's what it says, right? ChromaDB uses default metric is Euclidean. Now,
So I'm
Yeah.
sorry, one question here. So is
Yeah.
the model the Chroma or Pinecone? It's nothing to do with whether it is a OpenAI model or a Llama. It's not the
No. That is, we are still not there. So don't get confused. We are still
okay.
not there with the model, any of those models. This is just database and
Okay,
embeddings.
got
Just
it.
that.
Okay.
Okay. Yeah. Lakshman, you had a question? Unmute, Lakshman. Yeah.
So basically, it takes it takes these algorithms, right? We can explicitly also provide which algorithm it takes.
Yes. Yeah. I'm coming there. Yes. So,
And the second question is
yeah.
about the semantics. How it is going to decide what semantics, if it is particular to fruit or is particular to animal or particular to place or temperature, how it is grouping, like you're telling SQL query
The
in the first
grouping
place,
is done
how it
based
is
on
grouping
the
it?
grouping is based on the embeddings, right? That is why we are generating embeddings. So the embedding model.
We need to explicitly give that embedding.
No,
What is that?
we don't have to give anything to the model. It will automatically generate embeddings. Based on generated embeddings, they will automatically fall in different spaces. We don't have to
It
give anything.
understands
The model
intelligently
understands.
about
Yes, the embedding
the
model
fruit.
understands. Yeah, the embedding model understands. That is why we are using an embedding model. That is why we have so many models. Embedding models also, like small, big, different. For smaller ones, we have small dimension like 384 dimensions. For bigger ones, we have a dimension 1500, 5000 dimension models, right? More complex to understand more complex relationships and generate the embeddings. And the more complex it is, the more deeper it understands the meaning and get the points in a multiple dimensions. Okay.
Is there any situation that it doesn't understand semantics at all? Like, let's say you bring something, a different topic, it doesn't have that. So how that is grouped into which semantics?
We don't know. We're talking about the capabilities, right? So let's say you are using ChatGPT. Can you ask ChatGPT a question that it does not know? Yes or no? We don't know. So if it has been trained, yes. If it has not been trained on that, no. If you go to an old model, it may not give you a good answer. If you go to the new model, it might give you a good answer. So basically, you're talking about the edge cases. 99.9% of the times, yes, because it's a guarantee that the models have been trained on huge amount of data, whatever is available, seen, unseen, and seen data, right? So obviously, yes, we assume that they have seen everything and then can generate good embeddings. Now, how do we know it does not see, it does not know Apple, it has never seen an apple, or it does not know what an apple is? It gives you some kind of embedding. It generates some embedding, even if it doesn't understand. But it may not be very perfect. So you see the results are not very good. So that's how you understand that, it's not able to understand this data or something. So maybe you change to a bigger model. So you're using all mini LM L6V2 for simpler things. Just, text documents. You upload a novel and then you want to ask a question from it, get semantic results. Yes, you use simpler 384. But if you're using in a corporate kind of scenario where you have, as I said, troubleshooting guides, you have past tickets of the customers, you have the working playbook of the model, all of these in there. So maybe you need a different, you have error codes, you have possible solutions, you have diagrams to show. So maybe you need a bigger complex model to understand that. Or for example, images, you need a bigger, more different model. So it's just that you try to change and see which models performing better. But if you want to see how do I know whether it knows Apple or not, we don't know. Only we try and see whether we are getting better results. As I said, 99% of the times, if you use a bigger model, latest model, it may have seen all the data that you're trying to embed 99.9% of the times. Okay. Does that answer your question?
Yeah, done.
Okay, good. All right. So now the question we wanted to address is, can we give which model we want to use? So as I said, yes. You see here dimensions, we are using all 1536 here. Okay. Now last week also I have shown you. Now if I want to create, so this is the Pinecone. By the way, you all can go just create an account or just use your Gmail ID to create an account. It's free trial account, and it gives you up to, I think, 5 indexes to create. So I have, we go here, indexes, last thing is that create index, right? Now see here, you have some of the default models you can use, hosted models. Okay. So if you see here, these are already hosted. Now, if I use 3 large here to create, see the dimension, it is 124. Metric, you see, it is cosine, but it can also support dot product. So if you are trying to use Pinecone index with this embedding model, it will support these 2 metrics. It will not support the Euclidean here, or it will not support the Manhattan. It will support cosine and dot product. So you have to choose from this. So these are the options available. And dimensions also, default it gives 124. If you want simpler, smaller, go 256. This is good enough for me. I don't want more complex, complicated, because it takes more tokens, it takes more processing to search and do all of that. or I want a very complex doc information that I'm embedding. So I'll put 3072. So these are the options that are available if I use text embedding 3 large model from OpenAI to do the embeddings. And this is the max tokens that are allowed in, which means that my chunking, my paragraph, my sentence, I'm sending it should have this many tokens maximum. Okay, so let's say I want to switch Microsoft E5 large I want to use. See, now there is no option. If you use this model, you have to use 1024 and there is only one metric that is supported for this model. Maximum input is also only 500 tokens it can embed. It cannot embed more than that. So in your chunking, you have to make sure that each chunk is only 500 tokens. Now, if we go to Llama Text Embed V2 from NVIDIA, that is hosted on Pinecone. Now, again, here, see, there is an option. You can choose all of these, whatever dimensions you want. Okay, 1024 is cosine. But yeah, if you see, metric is only one. It is not supporting multiple metrics. Even though whatever dimension you are using, the metric it uses to calculate distances is only cosine similarity. Okay, does that help you, everyone? Any questions? These are all the hosted ones you can use to create an index from the vector database itself. Once you create from here, you can use it from anywhere to write data into this. Or alternatively, you can directly create from using the code also. You can ask it to create the index. So when you're creating the index, what you need to give? You need to give the dimensions. That's the most important part to create the index. And, which gives you can use the model that you are having to send the data into it. Any questions on this? How to create an index?
And we can use Pinecone only or to create the model, or
Pinecone
is
is
there
one of
any?
the vector database again. So if you go back, we talked about vector databases. If you go here, see here. Pinecone is only one of them. You have all of these, any vector database you can use. VV8, Redis, pgvector, Cassandra, Milvus, Quadrant, Lance, Vespa, all of these are available. And each
And it is
database,
free, right? Or it is
huh?
commercial? Is it
Yeah,
free or
either
commercial?
free or commercial, yes. So this is commercial, but you can still get a trial account, right? And these ones are free, and these are also have a commercial element to it. It's not free means only free, right? Commercial is also available for some of them. Okay.
Mhm.
So that's about the Pinecone. Now, if I go here, if I go back to Pinecone and I go to indexes, I have this semantic cohort semantic search earlier. It has some data. Now the data is that I have created, say, my embedding. Now, if you see here from my resume, I have uploaded my resume document and it has broken down into roughly 1,000 characters and put it in the database. And this is the ID for this, and this is the embedding generated for this. Okay, so you can see the values for the embedding also here. Like that, my resume has been broken down into 38 records. Okay, so this is what it is. I have put the data, my resume information into this, and then I can search any information related to my resume. Okay, now you can do search here, top to
Arun, can you show me
by,
how did you upload the resume?
sorry?
How did you upload the resume to here?
Yeah, I'll show you that. I will
Okay.
come to that. Okay. So, so if you want to search from here, you can search, or from the document search, vector search, you can do that. Okay. So no, not to worry about this, but I just wanted to show you how the data is stored in this. Okay. How we are getting data into this, will come there. Okay. So we have to give ID. I don't want to give by ID. By vector, I have to give vector. I don't have vector to search. So this is how it happens, right? It's by standards, by vector. We send a vector to search. It will search and give you the results. I don't have a vector right now to search, but that's fine. Fetch by ID, list IDs, update metadata, and all of that. Now we'll go back here and configuration on the, is there anything? This is the namespace. I want to see metrics. So this is the metrics, how many searches were made on this. Again, you get all of this, what is it a query? Is it an upsert? Is it an update? Is it delete? Is it fetch? Is it list? Okay. So we have a query, fetch and list that was run, 9:05 a.m. That's what it says. And you have all of these metrics. So we'll talk about what these metrics in the observability later in this training sessions. Okay. But yeah, so these are the metrics. You can see how many reads happened. So 9 a.m. there is 9:05 a.m. This is read. Write. When does the write happen? So there is no write here. Let's go back 12 hours. So see here, the data was written into this database at 12:38 a.m. Today on March 21st. So last night I have run this. So I inserted data into this. So it's about 12:38 a.m. We got, write units into this, 1.813 per second. So how did the data get into this, and how do we do the search, right? Now I'll go here, delete this index. Okay, that is okay. Now that is deleted. I have only 2 indexes: workshop, Chartbot, semantic search, fast. That's it. Now let's go back to our Pinecone here and go create the libraries first part. So we have to figure out what libraries we need from Python to, we are using OpenAI here, we are using LangChain here, we are using Pinecone here. Now, what is LangChain and all of that we will talk about, but for now, focus on Pinecone. Okay, tick token, all of this. So what we are trying to do here from the architecture, again, I will go back. We are trying to do this part. We are trying to upload a document, which I am doing my resume. I'm going to upload my resume to this as a PDF document. I'm going to do a chunking, break it down into smaller characters. I'm using a model to do the embeddings, and I'm writing to Pinecone database, masking the question and getting the results. This part I'm not doing today. This LLM, we are still not there. We are not using any LLM models. We are only using the embedding models. So this is what we are trying to do again. So as I said, we will be referring to this architecture so many times, maybe today, tomorrow as well. So let's start session. So we have installed everything. Now I'm using OpenAI API key and Pinecone API key. So how do I get a Pinecone API key? Same thing, just like we did OpenAI key. All you have to do, go to Pinecone using your Gmail, create an account, and then go to API keys here. Just create an API key, just name it anything, copy that key, whatever is generated, and come back and paste it here. Where in the keys, here you push the key, actual value here, whichever you're copying from there, and the name, you put some name here, pinecone underscore API key. So once you have set up this, you can use this block of code to read that keys and set up in the environment for the Pinecone. Also remember, you are setting up one Pinecone environment. You have to check which environment. I'm using US East 1 AWS. This is where the Pinecone will create the index for you. And again, you don't have to worry about AWS credentials or account or Azure account, nothing. It will automatically take care for you. All you have to do is just select. So because when I do a create index here, apart from models, I also get an option to choose any of these, AWS or Google Cloud or Azure. It will automatically go and create for us. We don't need to check or do anything for that. In that, we have a region once we select. If you want to select this one, Google, you also have these regions. If you have Azure, it will show some regions. So just select one of those regions. That's where it's going to create the index for us. Okay. Now I used US East 1 AWS. So that is the boilerplate, setting up the keys, variables. Now from PyPDF2, I'm taking PDF reader and character text splitter. This is to read the PDF document, my resume, and break it down into smaller parts, character splitting, text splitting. So I use this, and from Pinecone, import Pinecone and serverless spec. I'm creating a Pinecone object. API key is what we have set here. Use this API key. Environment is Pinecone environment, which is this one, where region where you are going to set up. Index name, I'm creating this cohort 8 semantic search index. If index name if it is not existing in the current list of indexes, then I'm creating a spec. Cloud is AWS, region is US East 1. It's same thing like this environment, but okay, I'm explicitly again using it here because the method uses differently, but it's the same information. Pinecone.create index with this index name, dimensions 1536. So see here, why I'm using 1536 here? Because I know I'm going to use OpenAI ADA 002 model to generate the embeddings. Now, if I go here, OpenAI ADA 002 dimensions, ADA 002 outputs a fixed length of vector 1536 dimensions. So that is why I am creating a dimensions 1536 index so that they are compatible. When I write an embedding, create an embedding using this model, I know the output is in 1536 dimensions. So if I want to store that in the index, that index also should have the same dimension. And this is the spec AWS East 1 Pinecone.index. Any questions? This is how you create an index in the Pinecone using your code from here. Let me know. Anybody has any confusion, any questions? This is all boilerplate code. I mean, even if you ask Gemini, it will automatically give you all this code.
Harun,
Yeah.
you mentioned about that key, right? That every time we need to configure the Pinecone. So it's like for initially in the last time you mentioned about the collab, OpenAI one, this one we are adding, right?
Yeah,
The
Pinecone. Yeah.
Pinecone.
No, you don't need to do it every time. You need to only once. That's it. You don't need to go and generate every time. Your API key you generate only once and store it. That's it. You just keep using that key. And this is free. You don't need to, I don't think they will charge anything. Pinecone is free. Pinecone API key, trial account or whatever account, it's free. You just create the key and use it. Okay.
I have done this up to configuration, Harun, for OpenAI. I think I need to configure this one too, but I haven't
Yeah.
executed any of this.
Yeah, you can
code
execute. That's fine. So let's say I'm running this and create the index name. So once this runs, we can go and check. Okay, that has run. I can just list directly from here. Let's see what it was. Okay. So if I list all the indexes in my Pinecone database, what are the indexes? So there is a workshop chatbot, what metric it is using, cosine for the distances, what is the host region, cloud, on demand, it is ready. And this is the dimension 1536 for this. The second one, see, this is the one that we have created now. Cohort 8 semantic search, metric is cosine, US East 1, AWS, this one. And there is another one, semantic search fast. So totally there are 3 now. We have already deleted one. There were only two indexes here. If you see workshop chatbot and semantic search fast only. Now if I refresh, I will get the third one as well. See here, cohort 8 semantic search. Now see the record count is 0. There are no records in this yet. No records yet. Okay, cool. Now the next part is taking the document, breaking it down smaller parts, generate embeddings, and push the embeddings, the data into this vector database. So this is the boilerplate code. This function, load PDF, it will take the file path, okay, and read it and extract the text and return the text of the document. Simple Python function. This function, chunking, is to break all of the text into smaller parts, small chunks. Here, this is the text string that we are passing, whatever we are getting from here, this text. And the chunk size, I am saying take 1000. And overlap is 100. I'll give you a document of what are the chunking strategies. There are so many chunking strategies. I don't know, maybe you should have some medium, or I'll see if I have already extracted that. I'll check and give you. It can be like fixed characters or fixed by sentence, by new line, by paragraph, by page, by section. There are so many other strategies that you can break the document into sections. Like I said, if it is your troubleshooting guide, it will have each error message will have one section. So you can break that document by sections, by the error code. And each error code will become one chunk, right? Something like that. So separator, I said new line, chunk size I have, chunk overlap I have, and return after splitting the text into smaller chunks. Then I say get embeddings, list of strings. I'm passing from here, whatever chunks. And then it will give me a list of float. Float is the actual embedding. And model, see here, I'm using text embedding at a 002. That's the OpenAI embedding from here. That's why I'm using the OpenAI API key here. I have set up already that key. Okay. this OpenAI API key I'm using because I'm using the OpenAI model to generate the embeddings. Good. Okay, let's generate this embedding, use this function. Now, upsert chunks. This is where I am actually adding the data to the pinecone index. So whatever chunks I'm getting, taking batch size, batch chunks, get embeddings. So this will call the get embeddings method, this method, to generate the embedding for the chunk. And I'm converting all of this into, this is all generated code, index.upsert these vectors. So this vector, whatever I have generated with the text, I'm going to add it to the pinecone database. This is function. Okay, I have to call this function to actually write data into that, right? And this function will get me the results. If I ask a question, string top k, default is 5, I can change it later. Again, get embeddings, we pass the question to the same get embeddings method that we defined here. It uses the same model to generate the embedding and return. Results equal to index.query. Now I am querying this index with this embedding, query embedding, top k, whatever, how many results I want. And also I want the metadata. So this is also function. So now I have defined all the functions. Next is to upload the document. So if I run this, it will fail because there is no file path, to do that. So what I will do, I have to make sure this file exists. So I go here, look at this. This is the folder. Click on the folder. Then there is an upload button. So use this upload button. And from your local computer, you can upload any of the PDF documents. Let's go here, open. Okay. So this path is this /content/ whatever your file name that you will give, that you will get. You can say copy path. And if you put here, so it will give you the path where your file is, how you can refer to this file. Again, you have, this is also in temporary in memory. Once you go, out of this session, this file will be removed. So every time you have to go and upload when you are testing it. Now I have the file here. Let's run this. It will load the PDF. It will create chunks. Now, what are the chunks? You can see here. So these are all the chunks that it has created. You can see so much of data. All the text data is here, created as chunks. Obviously, as I said, it is not in the very good format, readable format. You can understand the characters, text, everything here, but it's not in very readable form. Now, I'm calling upsert chunks to write this to vector database. See, if you go back, still there are no records here. Even if you refresh this, count is 0. Okay. Now I go here and run this code, upsert chunks. Okay, first time only you need to put this. After that, you can comment this out. If the data is already there and you're just querying it, you don't need to upsert the chunks again. So now if you go here, see, automatically updated. 38 again, same, you can see all of this document. So this is one part of my resume, led migration of legacy databases to Azure Databricks for Costco Wholesale. This is one project, one row from this. This is one, all, it's talking about all the technologies, integration, vector search, architecture, right? This is talking about the certifications that I have mentioned in the resume. So all of that. 1 second, let me see. Okay, so this is the resume. As you can see, we have all of this. And there is some section where it has certifications and badges. Some section it has skills and all of that. some sections it has projects, all of this. So this is what I have uploaded. This is what I have broken down into smaller parts, 1,000 characters each. Now, once that is done, uploaded into the vector database. Now I'm asking some questions. So I'm asking question, what are the projects executed from the resume? Of course, it will only get from resume. See, I said I didn't give anything, how many matches I want. So by default, I've mentioned here 5. So it will take default 5 and it gave me the 5 results with the score. So if you see the text, there's something about, see, it's broken. It does not start with the actual, hey, these are all the projects that were executed, 1, 2, 3, 4, 5 in a very structured format. It doesn't do anything. It just throws at you raw data. It is up to you to process this. That is not in the scope of vector database. That's why in the architecture, if you see, after we get this, we are feeding this information again to a model here. This model here. Now, the job of this model is to take this raw data and give you a formatted answer that is easy to read. That's what I was trying to get. Then your chatbot is complete. But behind the chatbot, it's throwing you some raw data. Hey, whatever you ask the question, your answer lies somewhere in these documents or somewhere in these chunks of data. Now you figure out where it is, how it is, and all of that. So it just gives you some raw data. Take this and go through it. You might find your answer somewhere in this. You don't have to go through the entire document from 38 chunks. Now you have filtered to 5 chunks which are more relevant to your question. But it's still not in a very, it's not a finished product yet. It's a raw data. You know the data is there somewhere here, but exactly we don't know where it is. Something like this. Again, talking about, hey, what are the certifications? So again, it says, see, there is a certified data engineer professional, data engineer associate, academic, partner trainings, GenAI, all of this. But again, there is some other information here, which is not related. You see here, digital transformation projects. Projects is not related to certifications. But here you see there is a Snow Pro Core certification, data engineer professional, right? So all of this is there, right? And then you see led migration of legacy database. This is actually a project. It's not a certification. But since you asked 5, it gave the most relevant 5 out of it. The next, your job is to get this to a model. The model will go through all of this, understand your question, and then look into this information and give you a proper answer. That is your completing the chatbot. That's part 2. We will get into tomorrow. We'll complete this with the model and see how the same answers will look like when you add a model to this. That is for the part 1 today. Any questions? This is the semantic search application where you get the results based on your question.
A question, Harun?
Yeah.
Yeah. So the search and the index that you created, all of this is part of the pre-version of Pinecone, because it was saying that I can only create 5 indexes
Yes.
to start with. So I believe you're deleting it and adding it. Is it all considered as long as it is finally tested only 5? That's what it is.
Yeah. Deleting and creating does not come into.
Okay. And the search of it, is there a limit to the search and ingesting data?
I don't think there is any limit. I haven't hit that limit yet. Anyways.
Okay, great.
You can practice as much. And if it is a limit, it will tell you it is a limit. Then you have to figure out to continue to use or wait or buy or but I don't think it has that limit, because we are only putting very limited data for it's just for learning purpose, right? We are not putting in GBs of data. I just put 1 document. Maybe you can try with 2 or 3 documents and see.
Okay. Thank you.
But yeah, most of the chatbots fail because you are getting irrelevant results from here. This is where you need to more focus on, is my chunking strategy correct? Is my vector database giving proper results? Most of it goes back to chunking, how I'm doing the chunking, how relevant are my results, do I need to do a re-ranking, all of that. Okay. All right. So we stop here. We'll wrap up. I will share the recording. I will share these two notebooks as well today. You can go back and refer. So tomorrow we'll continue from here. We'll try add the last part, the model to it, and see how we can get answers to these questions. Now, again, I will not be used the same pinecone. I might switch to another same 5DB or something in memory. But the point is, now once we get the results, how does the model take it and answer your questions? Okay.
Harun, I will connect with you today. I have set up this one, but I haven't executed the code to get it. But probably today's session, if you share, I will execute in Colab. The one which you executed, you're going to share that, right? The code?
Yes. Yeah. These two I will share. Sure. I will share these two notebooks, both Chroma and Pinecone, and I will also share the recording. But before executing this, you have to replace with your own key and your own, create a Pinecone account. You don't need to create indexes there. You can directly run this. But two things you have to make sure is get the API key from there and put it here and upload your whatever document you want to store and change the file name, and run this.
Okay.
Probably you can do with your own resume and see how it works. Okay. All right, sir. Any other questions? Thank you so much. Appreciate your time. If you have anything, ping me, or we can discuss tomorrow as well. So we can take it step by step. Amulya, are you good? Priya?
Yes, Harun.
Okay.
I may get some questions if I do it more practically.
Yeah. Sure. Absolutely. So tomorrow we will do this, and then we'll have some time for Q&A tomorrow. 30 minutes. I'll just do one session just to complete this architecture, and then we'll have some Q&A. We'll wrap this up. So that will be we'll be halfway through building chatbots. Next week, we'll start getting into how to talk to LLM and all of that, and agents and all of that from next week. Srilata, Shubham, are you good?
Yeah, actually, I have a question. If you can go to the slide where you show the nutshell of the pathway from query to the LLM, query, vector database, embeddings, and LLM.
This one?
Not this one, the picture slide. Where
Oh, the slide you're talking about. Yeah, this one?
Yeah, this one.
Mm-hmm.
So, what I understood is, correct me if I'm wrong, if we give a query, so that will convert into numbers, right?
Yes, embeddings.
And then that the related embeddings will be passed into the vector database?
Yes, to search.
Yeah, so and then it will search at the vector database, right? So in
Yes.
the previous example where you used that Chroma DB, you
Mhm.
said that embeddings are already available and you just
No.
create a
So embeddings are not available. What I said is, let me try this. I don't know if this work.
So the query, is it matching with the vector database or with the embeddings? Or both?
Just give me a second. Let me see. I'm not able to see this part where not able to see the. It's a whiteboard I wanted to check. Not seeing this Zoom. But okay. Long story short, what I wanted to do was, let me do this then. Let's go to here. See, what I said was, now I have a user here, right? And then I have a vector, I have an embedding model. Okay, this is embedding model. Then I have my vector database here. Right? So whatever I'm passing, the user question, it goes to embedding model, it generates embeddings and stores in the vector database, right? This part is clear?
Yes.
Okay, now in terms of the chroma, what I mentioned was, I have a user and I'm passing it to the vector database directly. So this is my vector database. Okay. Now what happens inside the vector database is, I have an embedding model here. So it goes here and then it stores here. So let's say this is the index. So this is the complete vector database. But within the vector database, it has a hosted model. That's what I was showing you, right? You have NVIDIA, you have ADA 003, OpenAI, small, large, whatever. There is some hosted database. Same thing, Chroma has some hosted, sorry, not hosted database, hosted model. Same thing, Chroma had that all mini LM L6 V2 here inside. So if you're not passing embedding directly, you're passing the text here. It will use the model it already has to generate the embedding and store an index. But in this case,
Yeah, got it. That was my question.
yeah, if you have
So
an
it can
embedding
go-
model, explicitly you can generate and send it to vector database, it will store here.
Yeah, got it. Thank you.
Yeah. I know this is not legible, but I'm happy that you got the answer. All right. Any other questions, guys? All right. Thank you so much. Appreciate your time. I will upload as soon as possible. The notebooks will be in the Google Drive. I think you all have access to that. If not, ping me, Harisha. She will provide access to the Google Drive where we put our decks and notebooks. Recordings, as I said, will be in the playlist, the same playlist. Every week we'll upload the recordings there into the same playlist. All right. Thank you so much. Appreciate your time. Have a good rest of the day. We'll meet tomorrow.
Thank you.
Thank you. Awesome. Great.
Thank you.